The idea with the future of making things is how can we start to think about how to make the next generation of our cities, of our houses. All of that can change because of the technology that we have and different approaches to how we create and think about things collaboratively. Where we are today, we're in the build space that is used by architects and engineers and creative people all around the world to create whole new things and whole new processes that don't even exist. We started this project that's ultimately going to be this Photoelastic Pavilion as a research project with Foster partners. Think about something like not making something out of steel, but making it out of a rubbery or a plastic material. How can you design that with multiple materials to build in certain movements or rotations into the object?
We wanted to see what we could extract from sort of the state of the art right now in material science and see what we could use here at the build space to kind of push that as far as possible in the scope of the internship. For Amira and I, it was a really broad spectrum for probably the first month of the internship, but the one that we extracted for the sake of this project were photoelastic materials.
So the photoelastic effect is you can dynamically visualize what's happening just by small forces and using a polarizing film.
Designing in a behavioral property to something that could be digitally fabricated is ultimately what Scott and Amira were trying to do.
We found that we could sort of hack the traditional implementation of these materials and use them in a much larger format than we'd ever seen them before, and use them more as kind of like a skin or a window-like surface that people could interact with and have kind of a playful relationship with.
They had this machine, the Howick machine, and on the first day they were like, this is your project. Take this machine and see what you can do with it. The way I framed the project was we're going to hack the Howick to make any geometry, not just lat walls.
So he came up with a novel set of ways to connect these Howick pieces together, these sticks that are just one-dimensional like lines, like bars, but connecting them in ways that are really strong and they're structurally really sound. So using this tool to make something that the designers had never even thought of.
A lot of time was spent strategizing geometrically how we put the pieces together. And then we developed software tools that made it easier to lay these things out in 3 dimensions and then spit out files to the machine. Dynamo has this really cool feature called zero-touch development, which is basically like you're doing very real software development for Dynamo, but it's easy. I was using that all summer to make a plugin that could go into Dynamo, and anyone can download it now, so that's a really cool thing.
The biggest opportunity that we have using tools from Autodesk is just collaboration and interdisciplinarity and sort of removing the barriers that traditionally made it difficult for people with different backgrounds to kind of share their knowledge onto a single project. The things that we worked on this summer, all were using kind of totally different areas of research that Autodesk is working on, but then pulling it all together with platforms like Fusion and Dynamo and Revit. What it allows is sort of pulling data and pulling information from disparate sources and manifesting it into something like the Howick structure.
I think these two skill sets, like design and software development, go together really well, especially when you have access to facilities like this.
With projects like these, we can actually help collaborate with the larger design and engineering community and start to take on some of the larger challenges that we have in the industry today.